the distance in midpoint formulas. All right, so let's say we're given the points -1, -3, and 5, 5. We're going to use a graph to try to figure out first what is the distance from point P to point Q, and then what is the midpoint of the line segment whose endpoints are P and Q. So in other words, imagine you were walking directly from P to Q, and you decided to stop and take a break when you were halfway there. Where would that be? That's what I mean by midpoint. Okay. So I have started a picture that will help us with this. I'm so used to doing this on an old school whiteboard that this is going to be something new for me. All right, so there's point P, there's point Q. Remember that P was -1, -3, and Q is 5, 5. So what I'm going to do is I'm going to draw as straight a line as I can from P to Q. Okay, it's not too bad. All right, and let's deal with the first question. The first question was, what is the distance from P to Q? Okay. So here's what I'm going to do to help me figure that out. I'm going to draw a couple of other line segments. I'm going to draw one going directly across the bottom here. And then I'm going to draw one coming down from point Q, or let's say going up towards point Q. So in other words, I've made this picture into a triangle. Okay. So I want to find the length of that longest side. How can I do that? Especially if I point out to you that I can pretty easily figure out the lengths of the other two sides. Because hopefully you can see that the length of this bottom side would just be the difference in the x coordinates, which would be 5 minus -1, which is 6. And the length of this other side would be the difference in the y coordinates, which would be 5 minus -3, which is 8. All right, so you remember how to find that missing side. We'll call it D for distance. We will use the Pythagorean Theorem, which says that D squared is equal to 6 squared plus 8 squared. All right, so in other words, D squared is 36 plus 64. 36 plus 64 is 100. So if D squared is 100, that means D must be the square root of 100, which is 10. It is exactly 10 units from point P to point Q. Okay, so that takes care of the distance question. The other question was the midpoint question. So would you find it reasonable if I said to you that the midpoint, which, where is that midpoint? Is it right about here, I think? Let's try that again. Oh, right about there. To find that midpoint, what if I just went halfway along the x and halfway along the y? All right, and that would in fact give me that point that I just labeled. All right, so it sounds like a reasonable way to find midpoint is to just find the average of the two x coordinates and then find the average of the two y coordinates. Okay, and that is exactly what we're going to do. So let me show you the formula. By the way, I kind of hate to leave this without answering it. So let's just write in what we just said. So for midpoint, we're saying we think we should average the x's to get the new x. So the two individual original x's were -1 and 5. So remember, to take an average, you just add them together, divide by 2. And then do the same thing with the y's. So the first y coordinate's -3, the second y coordinate's 5, divide by 2. -1 plus 5 is 4. -3 plus 5 is 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Okay, so that agrees with the point that we have labeled there. Okay, so now I'm going to throw a couple of formulas at you, which will hopefully seem reasonable, having seen that. All right, and here they are. So first we have the distance formula. The distance between the points x1, y1 and x2, y2 is given by doing this. So this formula looks kind of scary, but what I want you to remember is that it just comes from the Pythagorean theorem, okay? D is going to be the square root of the difference in the x's squared plus the difference in the y's squared, okay? So remember, the difference in the y's was the length of that bottom side. The difference in the x's is the length of that bottom side. I think I said that wrong the first time. And the difference in the y's is the length of the other side, okay? Let's say the bottom side and the side. All right. Okay, so again, it's Pythagorean theorem. The midpoint formula, I think, is a lot easier to remember. The midpoint of the line segment, whose endpoints are x1, y1, and x2, y2, is the point whose coordinates are x1 plus x2 over 2, y1 plus y2 over 2. In other words, just average the x's, average the y's. All right, so we're going to end by doing these two examples. We have two distance formula examples, and then we have two midpoint examples. So hopefully you'll try some of these, you know, before me. Pause the video, try it, come back, compare notes. Okay. All right, so one last time, back to the tablet. And here we go. So first we're finding the distance between 3, -2 and -4, 1. And I think I just remembered, oh shoot. Okay, that's what I thought. I almost forgot that in this problem, they want an exact distance and also a 3 decimal place approximation. Okay, so here we go. Whenever you use the distance formula or the midpoint formula, I strongly recommend, just like when you're using the slope formula, that you label your points. All right, so here's x1, y1, here's x2, y2. And then the formula is the square root of the difference in the x's squared plus the difference in the y's squared. Okay. All right, so x2 is -4, x1 is 3, y2 is 1, y1 is -2, be careful with your negative signs. -4 minus 3 is -7. The square of -7 is 49. 1 minus -2 is 3. 3 squared is 9. 49 plus 9 is 58. So that would be your exact distance, square root of 58 units, and your approximate distance from the calculator, just ask your calculator, what is the square root of 58? The square root of 58 to 3 decimal places is 7.616. All right. So now we're going to do letter B. So again, let's call this x1, y1, x2, y2. All right, the distance is the difference in the x's squared plus the difference in the y's squared. X2 is 0, x1 is negative root 5. Y2 is the square root of 7, y1 is 0. All right, 0 oops, I left out a parenthesis. 0 minus the square root of 5 is just square root of 5. Don't forget that's squared. And then square root of 7 minus 0 is square root of 7. Okay, so they rigged this problem to do something special. The square root of 5 squared is 5, isn't it? And the square root of 7 squared is 7. 5 plus 7 is 12. Now, whenever possible, you want to simplify these radicals before you give your exact answer. The square root of 12 can be simplified because it does have a perfect square factor 4. So you write that as 4 times 3, and your exact distance would be 2 times the square root of 3. So this time I skip the step where I write the square root of 4 times the square root of 3. And then I just barely have enough space to squeeze my approximate answer in up here. Okay, to 3 decimal places. Either the square root of 12 or 2 times the square root of 3. You can ask the calculator for either one because they represent the same number. To 3 decimal places, that's about 3.464. All right, just barely crammed those 2 examples on the same screen. All right, I think I'll have an easier time doing that with the midpoint examples. So again, x1, y1, x2, y2. The average in the x's would be negative 3 plus 6 divided by 2. The average in the y's would be negative 4 plus negative 8 divided by 2. Negative 3 plus 6 is 3. 3 divided by 2 is just 3 halves. Negative 4 plus negative 8 is negative 12. Negative 12 divided by 2 is negative 6. So the midpoint of this line segment is the point 3 halves comma negative 6. All right, and finally, very last example, same problem. Find the midpoint, x1, y1, x2, y2. The average in the x's would be negative 2/5 plus negative 2/5 divided by 2. Now let me just mention this would be one spot where thinking of it as average would be really helpful. What is the average of negative 2/5 and negative 2/5? It's negative 2/5. When you take the average of the same number twice, you just get that number, right? Isn't that logical? Okay, so it's one of those things where if you go ahead and figure it out, hopefully you'll look at it and you'll say, oh yeah, of course. All right, but that's not going to happen with the y's because those are not the same. 7/15 plus negative 4/15 divided by 2. All right, so you know what? I'm just going to go ahead and write that this first one is negative 2/5, but the second one, 7/15 plus negative 4/15 would be 3/15. So let's talk about what happens when you divide 3/15 by 2. Dividing by 2 is the exact same thing as multiplying by 1/2. Okay. So that's going to give you 1/2 times 3/15, which is 3/30. But 3/30 simplifies to 1/10. All right, so the midpoint of that line segment would be negative 2/5, 1/10. And that's going to do it for section 10.3. We'll see you next time.